Good day, everyone. I am Nathaniel Magallanes, your science teacher for the grade 7. So, this time we are already in the fourth quarter of Science 7. So, I hope that you are at home, safe and secure as you are having your learning video here in my video lesson, I mean. And also, I hope that you are following the health protocol set by the Department of Health. I encourage everyone to continue to participate and engage in this lesson because I prepared guide questions for all of you. Continue to cooperate and collaborate with the people that surrounds you at home if they are interested to join this learning video lesson. And I also hope that you continue to have a responsibility over your lesson or over your learning because this is important for you as you take your quiz and as you continue to perform your academic work. So let us proceed to this lesson entitled A Season for Everything. Same tree but four transformations. What is the cause of this phenomenon? So let us know the phenomenon behind this. Let us read the quote. To everything there is a season and a time for every purpose under the sun, a time to love and a time to hate, a time of war and a time of peace, said by King Egbert. These are the objectives of my video lesson. The learners will be able to use models and relate it to the tilt of the earth to the length of time. Number 2, length of daytime to the amount of energy received. Number 3, position of earth in its orbit to the height of the sun in the sky. Number 4, height of the sun in the sky to the amount of energy the area received. And lastly, tilt of the earth and the season. So let us proceed to the tilt of the earth to the length of time. Earth rotates on its axis. This causes us to experience day and night. But Earth's axis is tilted 23.5 degrees inclination. The angle is measured between Earth's equatorial plane and plane in which it orbits the Sun. Locations around the Earth's equator only receive 12 hours of light each day. In contrast, the North Pole receives 24 hours of daylight for a few months in summer and total darkness for 4 months in winter. Let us proceed to our guide questions. Number 1, what is the amount measured for the tilt of the Earth? And number 2, why the daylight or daytime 24 hours in the location of the poles? So I will give you 3 minutes to answer the following questions a while ago. So you can post this frame in the video so that you have time to answer or write your answers in your notebook. We have the answers. So number 1, 23.5 degrees inclination, and number 2, due to location of the poles and tilt of the earth. So there is another here activity. You need to draw the line and make a tick marks with labels to reflect the tilt of the earth. Let us proceed to the length of daytime to the amount of energy received. So as you can see there in your picture, you have the sun, and the marking of the blue is the sky, and the red are the incoming light energy coming from the sun. So you have there, on a clear day, if the sun is directly overhead, the intensity of the radiation hitting the ground directly from the sun is around 1050 watt per meter squared. On top of this, a further 70 watt per meter squared comes from the bright blue sky, giving a total of 1120 watt per meter squared. If it is cloudy, this figure will be lower. Referring to our picture there, sun overhead or in a 90 degrees inclination, and on the other side, right side of the picture, is the sun in 30 degrees above horizon. So it is in a diagonal direction. So in fact, the sun can be directly overhead only in the tropical regions of the earth, as shown in the picture. When the sun is lower in the sky, the intensity of the solar radiation is reduced because its rays are spread out over a larger area and because they must pass through more atmosphere before they hit the ground. At night, when the sun is below the horizon, the solar intensity is clearly zero. Let us study this diagram. So in the horizontal part of the graph, you have the time in terms of hours, and the 0 to 100, 400, 600, so on and so forth, with a unit of watt per meter squared over the day. So the diagram above shows, or the diagram here shows the variations in the solar intensity at the equator region of the Earth. At an equinox time, when the sun is directly overhead at midday, the time axis uses the solar time. Example, the sun rises at 6 o'clock a.m. is at its highest at 12 and sets at 18 military time, or converted it, you have a 6 p.m. A cloudless day is assumed. So you have there the time or the hours spent and the energy as reflected in the diagram. So let us proceed to our guide questions. Number one, how much amount of energy from the sun light will the earth receive during the daytime? Number two, what is the time range during daytime? And number three, is watt over meter squared a unit of energy? So let us answer the questions. So number one, 120 watts per meter squared. And number two, 6 a.m. to 6 p.m. And number three, yes, it is. So let us now proceed to the position of Earth in its orbit to the height of the sun in the sky. So here you can see the three different pictures, letter A, B, and C. So sky views of the sun show the effects of rotation, revolution, and orientation of Earth's axis on the path of the sun through the sky at equatorial, mid-latitude, and polar locations at different time of the year. Sunlight variability due to astronomical factors in the southern hemisphere is the reverse of the northern hemisphere patterns. Seasons are also reversed. This is taken from American Meteorological Society. So let us proceed to our guide questions. Number one, the supposition of the Earth varies in terms of several months. Number two, suppose you are in the Philippines, which among the three are best fit for the position of the Philippines in the globe, being the model of the Earth at mid-latitudes, yet in southern hemisphere or below the equator? And number three says Philippines belong to the southern hemisphere. What will be the appearance, of the height of the sun in the sky with respect to the orbit of the earth? So these are the answers. Number one, yes. Number two, at mid latitudes, yet in the southern hemisphere or below the equator. And number three, same with mid latitude but reverse patterns from the northern hemisphere, and as well as the season also reverse. Let us proceed now in height of the sky of the sun I mean in the sky to the amount of energy the area receive. So let us study the figure below. So you have different places. We have here Kyoto, Monterrey, Madrid, Montreal, Munich, Siberia, and Polo Norte. They have different locations in the globe, yet they have different angle of inclination in the earth. So we have also different uh, different values with respect to the location of the places here mentioned in this figure, with also the solar energy emitted towards the different places of the earth, specifically in the northern hemisphere. So let us proceed in our guide questions. Which name of a place have a lowest energy received? And number two, how much the amount will the place named Quito receive from the solar energy? So here in my lesson, I already integrated here the mathematics because I use here numbers and units, and I also label the parts of the angle of inclination. And here I also integrated here the English or the language, which is the English language, since I correctly state my questions properly here in my lesson. So let us proceed in the answers of the question. Number one, which name of a place have a lowest energy received? The answer is Siberia and Polo Norte. Number two, how much amount will the place named Quito receive from the solar energy? You have the 2.32 megawatts hour per meter squared. Let us proceed to the tilt of the earth and the season. The solstices are the days on which the Earth's axis points either directly towards or directly away from the sun, one in winter and one in summer. The equinoxes are the days on which the Earth's axis points neither away nor toward the sun, the days during which night and day are the equal length throughout the world. The second figure shows the same four seasons on Earth. Our viewpoint has shifted, and we, the Earth, as it would appear from the above, the North Pole, click, and you'll see the pattern of the light and darkness, which is the day and night pause, with the portions of the Earth facing toward and away from the sun. In December, the northern hemisphere is tilted away from the sun. There are two specific effects which contribute to the cause of the season. Number one, the surface of the northern hemisphere is hidden in the Earth's shadow for more than 12 hours of the day, making the days shorter and the nights longer. Number two, the sun rises far in the south and never moves high enough above the horizon to stand directly above us, even at noontime. The surface of the Earth is thus quiet inclined to the incoming sunlight, and so there is less sunlight to absorb per unit area, and the climate is cooler. This is exactly the same as the poles receiving less light than the equator in our first case, as was shown in the second figure above, or here in the left side of the frame, right hand side. I stand corrected, it is in the left side of the frame. At the same time, the southern hemisphere is tilted toward the sun. The surface is lit up by the sun for more than 12 hours per day, and so the days, are longer. The sun rises to the north but not far north, and is found overhead at noon. The surface of the Earth is inclined perpendicular to the sunlight, as in the left-hand side of Figure 2, and so receives the maximum amount of sunlight per square area. The situation is most extreme at the north and south poles. At the south pole, the season is one long, cold night, which lasts for 6 months. At the south pole, the sun never sets, and it is warm for 6 months continuously. In March, the two hemispheres have 12 hours, days, and nights and receive roughly equal amounts of light. The sun rises at the equator, and the closer to the equator that we stand, the higher that it rises in the sky at midday. Notice that this even-handed state persists in all three of the three cases which we have considered. The Earth tilted by 0, 28 degrees or 90 degrees. In June, the situation is reversed from December. The northern hemisphere is tilted toward the earth and enjoy longer days and more sunlight during the day. The southern hemisphere is tilted away from the sun, hidden in the shadow of the earth and more than 12 hours every day. And when the sun is shining, it receives less sunlight per unit area. September has weather very much like June. The two hemispheres have 12 hours, days and nights, and receive roughly equal amount of light. The northern hemisphere has autumn weather because it is transitioning from summer to winter, which is the days start out long and get slowly shorter and cooler, while the southern hemisphere has spring weather because it is moving from winter to summer, which is the days start out short and get slowly longer and warmer. Excuse me. The figure below shows the Earth at each of the four seasons and the sunlight which fall upon at different latitudes. Let us proceed to our guide question. Suppose today is June. What will be the season? Number 2, is it summertime during month of May and April in the Philippines? Or do you agree with the answer springtime? You state your reason. Number 1, answer, it is spring to summer. Number 2, vernal equinox to spring. So I will state the reason here. Stated summer for April and May due to hot atmosphere. So let us proceed here to our next part of our lesson, showing what causes change in the season in the Philippines using models. So the Philippines, being a tropical country, receives ample amount of sunlight all throughout the year. Several wind patterns and phenomena like monsoons and trade winds are the main factors that affect the seasons in the country. Instead of having the four typical seasons, the Philippines only experiences two seasons, the dry and wet seasons. The wet season happens from June to October. This happens when southwest monsoon starts to be experienced in the Philippines. The dry seasons happens when the northeast monsoon blows its wind in the Philippines from November to March. The Philippines has four types of climates which vary based on the prevalence of the dry and wet season. Type 1 climate is characterized by a dry season starting from November until April. The rest of the year is wet. The Ilocos region and Metro Manila are two areas which has this type of climate. The type 2 climate is characterized by the absence of dry season, but with only little rainfall from November to April. The province of Surigao and Agusan in Mindanao have this type of climate. The type 3 climate is characterized by an absence of pronounced seasons. It is relatively dry from November to April and wet during the rest of the year. The islands of Romblon and Marinduque experience this type of climate. The type 4 climate is characterized by a more or less evenly distributed rainfall all throughout the year. The province of Bohol experience this type of climate. The dry and wet seasons affect the different parts of the country in many ways. For example, farmers plant rice during the wet season and harvest their produce during dry season. Cool areas have robust tourism industries, specifically during hot summer months, while some areas are constantly economically challenged due to frequent storms. So here is the climate map of the Philippines in the modified Coronas classification. So already mentioned them, the type 1, type 2, type 3, and type 4 climate. So let us focus in our region 6, which is the Panay Island. So you can see the red part and the yellow part of the Panay Island. So here is the guide questions. Number 1, what climate suited for the Panay Island? Number 2, how many seasons we have in the Philippines? Okay, let us proceed to our answers. Number 1, West Panay will have type 1 climate, while East Panay will have type 3 climate. Number 2, we have two seasons, the dry season and the wet season. So, to sum up everything, the Philippines only experiences dry and wet season since it is near the equator. There are four types of climates in the Philippines based on the prevalence of either dry or wet season. So go ahead and take your quiz. Write the correct answer in your science notebook. How much is the daytime length of time of the Earth? That is number 1. Number 2, how much energy the Earth will receive from the sun's incoming solar energy? Number 3, what is the degree inclination of the tilt of the Earth? And number 4, what is the season? Suppose today is December 21. Number 5, what do we expect? Suppose it's 1 p.m. in the afternoon in terms of the height of the sun. Let us proceed to our answers. Number 1, 12 hours. Number 2, 1,120 watts per meter squared. Number 3, 23.5 degrees of inclination. Number 4, winter solstice. And number 5, sun in its maximum height of the day. So your assignment for the next session that we have, you need to present from your notebook. You need to draw a view from your home regarding the sun's height from the horizon during 4 p.m. in the afternoon. Or you can take pictures of the sun during 4 p.m. of the day. And number 2, why we get too much energy from the sun during 1 p.m. and not during 4 p.m. You need to state your reason. So you have two activities for this assignment. So thank you so much for staying in my lesson. God bless and be well.